if anybody didn't watch the video or wasn't here last time, what we did was we looked at the idea of a Kanban application. If you're not familiar with them, I'll quickly go over it. I don't want to spend too much time for the people who are here, but it's an application that basically it's more complex to do app. So instead of just to do that, you can check stuff, done, not done, etc. You can have different columns with give them different states, whatever you want to call them. You can add as many lanes as you want. You can add notes into each one, and then you can sort of move them in between so that they represent where they're at in the different states. Overall, conceptually, pretty simple. And then what we did was we sort of looked at what the different aspects are of building this out. So we looked at what are the components that you would do if you were building this in a React application. Then the hierarchy, how would you compose those components together to build a React app? The state, so what bits of data do you need to hold on to when you're building it out? And then what are the actions? So those are sort of the things that the ways that you interact with the application, and actions typically change your state somehow. I mean, we really built out the concept of how you would build something like this. We just didn't implement stuff in the code. But we began to see, part of what we saw when we did this was some of the limitations that you run up against if you tried to use just the component state to manage all of this information. Because as we built it out more and more, we realized that really the app level, the top level component for this application would have to manage all of the state in order for us to be able to accomplish the different things, particularly the challenge of moving a note from lane to lane was the most challenging thing to do, that really required us to move all of our data up to that top level in order to manage it. And so that leads to a really complicated app level component that's managing all these different aspects and has to pass down all these potential different sort of action event handlers through to the rest of the application. So what's happened is we built out, it just sort of ends up happening that your app component, that top level component, becomes very, very complex, and all the other bits of your application have to know how to pass different things through that they don't even care about directly. Like, oh, the lane may not care how to edit a note, but the note cares. But because the app is what has to manage all that, it has to pass that all the way down through the lane. So now the lane is connected to that in some way. So sort of the reason I chose this example is it's very, not too complex, but it's complex enough to begin to see the challenges of living with just set state as the way that you manage mutating data in your React application. So today, what I want to do, and this isn't something that, this isn't like React where I'm saying like this is a core concept, probably won't have any direct assignments on this like to work, but I'm showing you one of the popular options out there to manage this state in a different way. And for probably, I don't even actually know if we're going to get all the way to hooking it up to React components, because there's a lot to using Redux. So I'm going to start off with React sort of out of the picture and just thinking about the state, the information that we have, and how that stuff changes, so that we're not mixing both pieces at the same time. And then eventually we'll come revisit this idea of hooking it up to React. You know, if we don't get there today, then I might just do a separate follow-on video as opposed to taking up another class with that concept. But like I say, Redux is one of these sort of popular solutions for this. These are all heavily influenced by something that's called Flux from Facebook itself, the people who did React, which is just sort of a way of managing data. Flux wasn't really an implementation of anything. It was more here's how you could do something. Here's how stuff could communicate. So this will hopefully make sense as we start working through it bit by bit. But before we start working through how we'll put data somewhere and how we'll change it sort of separate from our React application, not as set state, I want to go over these three principles that Redux has. And I think what we'll see when we go through them just real fast is that they reflect a lot of what I've been talking about in terms of good React development practices as well. So first concept is this sort of single source of truth. This is really unique to Redux. So a lot of the other data management or state management layers don't have the same one. This is one of the pieces that is most unique to Redux, where it says you try and store the state of your whole application in an object tree with a single store. So don't split it up into different pieces, store everything at one place. This is the one that's the hardest for people to get over when they start working with Redux, this idea, especially experienced developers who are used to data being sort of scattered around the state in all these different places. And it's probably the hardest one to explain the value of initially, but some of the, again, I talked about it when I was doing the editing, like the undo redo capability. It makes it very easy if all your state's in one place to manage any undo redo, because you don't have to go change things in multiple different places or worry about what bits changed in different places. And this also makes it easier to sort of monitor and interact with your state changes. And we're going to see that as we work through stuff today, because I will be pulling up the Redux developer tools and you'll be able to see some of what you get to see going on in the state changes. The next principle, and this is a confusing one because how could this be true? And so it's a little misleading, but they say state is read-only. Oh, that sounds very similar to, so we have two ways to pass or have data passed around in a sense in a React application. We've got state, and then what's our other way? How do we pass data into a component? Props, right? And props are read-only, right? And so that's sort of the same model here. The idea is it's not saying that the state doesn't change. It's saying that you don't directly change the state, that something else, and it's like you don't take an object that got passed in and then change the values of it. So if that's the case, and you're not supposed to do that, how do you change the state? Well, what it's saying is you send an event saying, Redux or whatever this thing is that manages the state, I want you to change the state in some way. It changes it and gives you back the new state. So instead of individual components modifying the state, just like individual components shouldn't modify props that get passed into them, this is sort of that same model where individual components or individual bits of code don't change the values of the state. They send an action that changes it, and then they get notified that that state changed. And then, again, this very much reflects what we've talked about with React components. Changes are made with pure functions, right? So we talked about how the best approach when you're building your React application is to try to isolate the sort of impure components, try to write functional components if you can, try to write things that don't have state or don't mutate or don't have side effects. And that's the same rule for the Redux tree, is all of the changes made in your state should be pure. So you shouldn't be changing anything outside of your state tree when you're making a change. And that also means, just like it did say sort of read only, but you, just like we showed with that array challenge where it's easy to accidentally mutate your array, in React, Redux has sort of those same restrictions, those same things. Don't mutate something, don't mutate an object, create a new object and then change the property on the new object and save that in your tree. So never change something that already exists, create a copy of it and modify that copy. So those are sort of the three rules of, three principles, if you will, of Redux. The interesting thing about this is it says three principles. There is nothing in Redux, there's nothing in the code that enforces any of this. So these are purely enforced by the way that you write your stuff, the way that you implement your code. But there is a reason for it that hopefully will make a little bit of sense as we go forward, but it makes a lot more sense when you build more stuff with them. So getting past that, let's dive right into trying to build something out with Redux. And they've got sort of three different pieces here. they've got the idea of actions, reducers, and a store. So I am going to sort of work through stuff in the same order, although to me, logically, starting with the store makes a little more sense. But just because of the way stuff is built, we'll sort of flow in the same order, but we're not building out the exact same example as them in their code. So theirs is more of just a very, very trivial to do, only one to do. And we probably won't implement all the bits and pieces of our stuff, but at some level, like at the action level, it's going to be pretty easy for us to say what the actions are or what types of actions we want to have. And so we can start to create some of that. So if we look at what we have here, the actions, really, we don't have to pull in any Redux bit of code at all to define actions, because all actions are just basically constants that are just a way to say like what action is taking place. And this will make sense as we build out the other pieces why this matters. But this is almost like defining functions, but it's just defining what action can happen. So that's really all that the action bit is at first. And so that's what we're going to sort of start with is let's, at the very beginning, sort of starting project here, React application. Normally I would put this stuff in a separate, maybe I will. Put it in a separate folder here. And then I would create some files like actions.js. So in here, let's start defining what are the actions that we want to be able to take in our application. And I have this stuff over here so we can, let me see if I can do side by side. All right, close this. So we had, what are our actions? We even had them up here. But we may not use these exact same names. So let's just create some constants very simply for what these different actions are. So what is our create note? And usually what you do here, there's no rules on how to do this. Exactly. There's some restrictions. You should use strings probably, but there's nothing that forces you to do that. It just needs to be something that's unique, whatever the name is. And this is going to look a little weird at first, right? So don't worry about how weird it is. Like, what are we doing? We're just pulling something over into this code. But let's go ahead and just, so what's some of our other actions we have here? Add lane. If we want to stick with our same naming, we could be like create lane, right? And in case you're wondering, it's just a little bit of a convention across a lot of programming languages to define constants like this that should never like change values as all uppercase of some kind. So if you encounter that in a lot of programming languages, that's sort of saying like, this is a constant. This is something that doesn't change. It's not really a variable. It's just bam, that's what it is. So create lane, what else we got? Maybe we'll skip, I'm gonna move this down. I think that one's a little tricky. What? Delete, I'm gonna be lazy here, watch this. We have delete note. We also have delete lane, right? All right. What else? Edit note, and we could say note text. I mean, we could do whatever we want here. I'll just be lazy at first. I'll say edit note. All right. Edit lane. I mean, it's gonna make my stuff not line up, but I'm gonna do the full thing here. These don't, like, again, like I said, these don't have to match the way that I'm matching the string to the constant name. It's just sort of a little bit of a convention. All right, these are the sort of trickier ones. So maybe start with the last of the two left.
Reorder notes.
Yeah, reorder. I don't know what to. Reorder notes. Sure. And we may not get. We're not going to get to implementing all these. So, and then. Change lanes. I don't know. Change note lane, something. There's no hard and fast rule. It's a common saying in computer science that there's only two real hard problems, cache invalidation and naming things. So literally, this is going to be an honest thing that happened today at work. We have a bit of code. So I think these stories are great because it just shows you how silly this stuff can be. We have a bit of code that we have struggled with every time we have to look at this code for 6 months now. And every time we look at it, we're like, oh man, this is so hard to figure out what's going on. And part of that's because like the customer who's using our code can pass in their own bit of code to be called when it's done. And we were calling that like the success callback thing. They get called when stuff's done, but we also have to invoke some code when something's done. And so it's been confusing for us for forever because it's like someone today again was like, oh, but the success callback is only conditionally called. Like, is that okay? What happens if it doesn't get called? And I'm like, no, that's actually the customer callback, not. And all of us were like, why haven't we called it customer callback? That makes so much more sense and would be way less confusing. I'm like, everyone all at the same, oh my gosh, I cannot believe we've named it this other thing this whole time, and it's confused all of us just because the name was sort of misleading, right? So naming things is really a hard problem and can add a lot of value and clarity to your code, but it's a hard problem and everyone names things wrongly at times.
Do you work in this building?
No. I work over by right by 40 and 54 and 55. So okay, so we've got some actions. Great. This is useless. What's the point of having some actions? Does nothing for us, right? So the gist of these is, and this is where we start to get into some of the conversation about how Redux stuff works, is the only way these actions are going to be used by this next thing we're going to talk about are reducers to change our store. So the actions are basically a way to tell the reducers, like for them to know whether or not they care about changing something. And we'll get into it, but what we're going to do is build objects a lot like this, right? So you're saying, okay, we've got an action that doesn't do much on its own. We're going to create objects that carry a type, which is going to be an action. And then the other properties of this object can vary depending on the action. So this is the only required property of each action that we send into our store to process is every one of them is going to have a type. And that's why we just created all of these action types, right? But the other bits of it will vary depending on what the actual action is that we want to perform. So actually, I do like what they said here, and I totally forgot that. I'm going to rename this real fast to action types. So now what we're going to do is start creating some very simple action creators to create an object of an action type, assuming that they're given the rest of the information that they need to create that. So I'm just going to go ahead and create a file here just like we had before, action creators.js, a lot like our action types. And we sort of, now we'll rename these things. but we sort of have some stuff here that should work for us almost already, because remember at the end of the last class, we created these, we said, oh, these would be like the functions, these event handlers that we would have to pass down, these callbacks. So, oh, I did forget something. What's the best way to do this? I'm going to look and see if they've got something cleaner than what I would do, but probably not. All right. It might work, actually. Let me see if this will work. I think it will. All right. So I'm exporting every one of these actions from this file. That way we'll be able to import them over here as we need them. So I'll start with import. All right. We need to import. Yes.
Can I do what you did on Cloud9?
I just selected everything. And yeah, I did. So that's a good question. I used a multi-cursor. I'll bet Cloud9 has some support for it, but I don't know how to do it. So the way I did it on here, do like a, let me see if it works. If you hold like maybe it's Alt or Command, you can click in multiple places and get multiple cursors. I think it's Alt or the Option key on my Mac. So it might be the same thing. I don't know if Cloud9 supports that or not. Multi-cursor is pretty slick. Let's see. Yeah, it may not support it. The way I did it on here in this case was inside a Visual Studio Code. If you do like Command D on a Mac or like Control D, it'll select. So if you already have something selected, when I hit that, it'll select the next item that matches that exact same thing I have selected. So I just selected everything and did it that way. There's probably more efficient ways to do it actually, but I don't know. That's really the only way I know how to do anything multi-cursor. Multi-cursor is pretty awesome though, because it's not limited to what you can do. Like I can move around and edit, like delete this stuff, do whatever I want. So, all right, let's import. We're going to import this stuff from our action types. I'm going to start with, let's do the first one. We're going to have to import a bunch of these, and I'm going to split them line by line so that they read easily. We'll import create notes, because that's sort of the first thing we're going to create. And then I'm going to comment all this bit of code out so that it doesn't cause the problem. So I commented out the later ones. This is a function. We'll call it create note. I like to double check what they call things for some of their stuff, just because it's nice to not be too far off. So create note. We know it needs a lane ID, right? So that's going to have to get passed into it. And other than that, this is really quite simple. All this thing needs to do is return an object with the information that whatever our store is and our reducer is going to need to modify our store and add this extra note to it. So it's in this case, it's a really basic object. We have to have the type, and we already know what our type is for that. Let's just create note. That's why we imported it. And then the other thing it needs is the lane ID. In this case, since I'm going to name this variable the same as my name here, I can use the shorthand notation of just saying lane ID. I don't have to type it out like lane ID is lane ID. This is just a nice syntactical sugar shorthand bit. Does that make sense? It's for lazy people. All right, so I'm going to need to export this function too. Create note. That's really all there is. first action creator, this most basic one, right? Oh, we may want something else. Like there's the potential that we want to have some default text in our note when we create it. And so right now I'm going to leave it this way with nothing else. But we could potentially include some default text here as well, saying like, oh, that's another bit of information that we want to pass into this stuff. We'll decide where we want to do that in a little while. Sort of keeping it about as basic as possible. Right, and then let's say we also have create lane, and in this case, it's just pretty much as simple as create note was, right? Nothing. In fact, even simpler in a sense because it doesn't. We don't think it needs to take anything right now, right? It just needs to return a new object with a type. So I need to import create lane, and this will just return a new object with a type of create lane. That's really all we need. At least that's what we think we need in order to create a lane, right? Another thing that's a really nice reflection that we've talked about is this should also reflect the notion I've talked about of not having to think about the whole problem at once. You notice I'm not solving all of the other bits of how to create this lane. I'm sort of just creating a type, an object that says like, you can do this. This is the information you're going to need. This guy will take it in, put some stuff together, and send it off. This is also a little bit of, in most cases with Redux, this is some of the stuff that really annoys people because there's a lot of boilerplate, a lot of just typing stuff out that feels like a waste, feels busy. And so there's some things that can reduce this, make it automated, you know, get rid of this boilerplate. Or sometimes these action creators can be much more complex. It depends on the way you want to build your store. So does this stuff sort of make sense so far? Yeah? So the thing we're missing right now is, well, we're missing a lot of stuff, right? But we're creating some sort of action. But one thing is, how are we going to tell it to do something with this action item that we created? And so they've got some notes here talking about how you dispatch it. And that's how it's bound. We're going to get there in just a little while, but we're sort of going to build out the pieces first and then hook them together. So they're gonna live a little bit independent at first, and we'll keep it pretty minimal. So the next bit we're going to do is the reducers. And the weird part about this is this store bit, the reason it's sort of at the end is even though we've talked a lot about our data structure and stuff like that, the reducers are really the thing that sort of represents most of that. So a reducer, if anybody, this should sound similar to if people remember like arrays, for example, have a .reduce function. That's an option on them, and what it'll do is take, we worked an example of it previously with like the clocks stuff and the sum. A reduce takes like a starting point and then it iterates over each item in the array and adds it to this running total and then returns the total at the end or whatever. There's a reason it sounds like very similar because it's sort of the same concept. The idea is it takes all these different bits, puts them together, and gives you back one item in the end. So a reducer is the bit that specifies how you actually change your state in response to an action sent to the store. So they say, remember, an action only describes what happened, but doesn't describe how the application state changes. So we've already, it says it's a good idea, again, walking through this, it's a good idea to think of the shape of your store before writing any code. Well, we've already thought about that a fair bit, right? We've got what we think is a pretty solid state in this right here. So we sort of have an example. So now let's talk about what a reducer is and how it works. Again, like I say, it's looking like I probably won't get through everything around this. we're definitely not going to build out all the other bits, the stuff for all of them. But a reducer is very, very simple concept. It's, again, this looks very similar almost to what a reducer does, right? In an array, it takes your previous state and it takes your action and it returns a new state. So that's all a reducer function is it says, oh, give me whatever the state was before and whatever action I'm want to take, and here's a new state of some kind. Like, again, it's called a reducer because of the way it works here. So we're going to, yeah.
This is the documentation, scroll up a little bit, it talks about you should never call on your function.
Mm-hmm.
Can you just translate just briefly what that means?
What a pure function is?
Maybe that's not.
It's not super simple. You'll find disagreement. The cleanest way to think about a pure function, and I'll talk about a couple different concepts around it. I do think it's really important to try to understand how they work. So you'll hear function, the output is the only thing that changes the output is the input. So in other words, a pure function is a function that doesn't depend on like an external bit of state or something else to change its value. It's what it, like, you would be able to test a pure function by passing a value in and seeing what comes out and knowing that that's how it should always work. So they're very, very similar to the concept of a mathematical function, right? Like, you can have a function that you put x into and you get out x squared, and that's like a pure concept because whatever x you put in, you get out that same result every time, and it didn't change because somebody had changed some other bit on the system, right?
Yeah. So those two just really quick examples, date now and math.random, are like introducing other bits of data
that are changing over time, right? Because if you have
different every time.
Yep.
Okay.
Because if you call date.now, if you have a function and I don't know what it does, like it adds, let's do something really stupid, adds 5 to the current time or whatever, right? And if it gets the current time inside of itself, so date.now, then you can't test that, like you can't run the same test with that thing twice because every time you call date.now, it's going to be a different time, right? So your value is changing based off something that isn't just the parameters that you passed into it. Math.random is the same way, right? It's going to be different. Now, with that said, that's the most common explanation, but there is a more strict definition of a pure function, which is that it doesn't have side effects on the system. So that actually means like if your function calls like console log, for example, that's a side effect. It's changing another state of your system other than just the inputs and outputs. So depending on who you talk to or the way you're thinking about it.
No side effects.
Yeah. But depending on the way you break it down and think about it, that technically, again, there's a lot of variance in the way people think about this stuff, but that technically would be an impure function as well. A lot of times people don't think about that or realize that that's the case. So most of the time you'll hear people say like, oh, the input is the only thing that affects the output. But actually, you shouldn't have side effects either. And it's very easy to have side effects. And once you get into that, you can get into a whole philosophical argument about, well, if my function took longer to run, then that's a side effect because now the CPU is in a different point in time than it was before. And so there's no real pure functions. It's purely theoretical. Anyways, and yes, those debates happen. But yeah, this is the same way. Remember, I don't know if you remember, this date.now is a great example. Remember I was doing that inside of my render function when we were doing our stopwatch originally to calculate some bit of logic. And I said, oh, I shouldn't be doing this in here. I need to pull this logic up and out of my render function. It needs to go somewhere else. That's that exact same reason. Render should really be pure. And by having that in the render function, that meant that I was really mucking with some fundamental aspects of React. So now we're going to create our reducers. And what we're going to start with, I want to see what they call their file at the end here. Just reducers.js. So this is going to be a little weird at first, but we just had the same. We just talked about how a reducer is really, the initial state or the previous state and an action, and produces your new state, right? So let's, in our store, same store folder, I'm going to create a reducers.js file. And this, we're eventually going to get all these bits hooked up so they work well together. But we're going to start with just the very basics. We're going to call this the Kanban app reducer. And we already know it takes two parameters at the top level, right? It takes whatever our current state is. Usually it's just called state. You don't usually write previous state. And it takes whatever action we want to perform. And what it's going to return is whatever our new state of our Kanban app is. So the most, what's the word on this function? Degenerate meaning most basic, most trivial version of this that we could possibly write is very simple. We just return the state again. The action never changes our state, right? That's a valid function, and it's even a valid reducer. We've got the most basic, simple reducer that we could possibly write here, where it doesn't care what the action was. It just returns whatever state we had. So, all right, but that's not really what we want to do, right? That's a little silly, but you can see they do the same thing here too. So let's do something else too. And I'm going to use a little bit of I'll use the same trick they're using here because I think it's really handy. So the first question you should have is, how does this get state in the first place? Let's assume that this reducer gets called originally. Where does it's in a sense, where does the state, how does it start with the state, right? Okay, well, whatever calls it needs to pass in a state. But what if the first time you call it, there isn't a state to pass in? Your application doesn't have a state yet at all. So one little sort of trick that people will do is to give it a default value so that if you call this the very first time with nothing, it's going to essentially initialize the state of your application. So that's what we've done here is if we called this now, it's initialized state and it'll return that initialized state now. So we could say, oh, this is our initial state of our application, right? And maybe we go, well, that's useless state. It'd be nice to have a little more. We'll get to that in just a moment, but we could easily, and we may not use this right away, but let's say we have we'll create an initial state, and we already have an example of what we want our data to look like, right? We want lanes and notes and stuff like that. So we'll initialize some state here. We're going to initialize an array of lanes. It's only going to have one item in it. It's going to have an ID of 1. And what did we say a lane has? A name? Name of, I don't know. Just sort of initializing something, right? Whatever I want. We're going to have notes. And this is just going to be an array again, just like the other one. We'll just have one initial note. Let's give it an ID. Again, 1, I don't care. And let's give it some text. New note. I'm not going to, I'll even give it a lane of 1. I don't know. So now if we wanted to, because this is just it's just an object with some other stuff in it, we could say that our initial state, if we didn't get anything else, is initial state. And now we're going to start with some data, sort of boom, bootstrapped our little app, right? Now we don't have anything hooked up using this data. It's sort of useless right now. But you can sort of see a little bit of where we're going with this. So the next step is going to be, well, we want to be, I keep going back to that side. We want to start hooking up. So we want to change our state somehow, right? We want to be able to change our state if something happens. If one of these actions gets sent to us, because these are the actions that are going to get sent. So let's look at our first action, which is create note. All right. We know that this is one of the actions that can get sent to us. Let's minimize this guy. So now this is going to be a little hard for you guys to think about, but let's say this guy could get this object with the action of create note. How would you go about handling that? We're not certain that's the action it's going to get, but it might get that one. You can just write an if. If the action dot type equals, and now we go, oh shoot, I need to import these actions over here, right? / action types .js. So create note because it needs to be able to know what it is. And now you see why I'm using these, you might begin to see why I'm using these constants, these variables. I could have written this out as a string here. This could have just been like create note. I didn't have to create the set of constants somewhere else. Then everywhere in my code would have to use that same string. I'd have to copy that string, create note, create note, create note around. And it would be easy to like maybe make a mistake and have them not be the same thing. It's almost impossible to make that mistake if you're using variables. So that's why it's sort of useful to have this very basic set of variables that you're using. All right, so we want to do something. We want to change our state somehow if the create note action was sent. So let's look at what our state is. Shouldn't be too bad. What do we think we want to do? So if we got the create note action, which comes in with just the lane ID, that's the only extra other bit of information that we're going to have with it. How do we want to change our state? What do we want to do to our state? Yeah.
Well, I think we want to add a new note object.
We do. But one got you there. Just like we had with React, again, we don't want to mutate our existing state. We want to create a new state. So it's going to get a little verbose here. It's going to be a little...
that where you kind of copy the array?
Yeah. It's going to be a little busier than it seems like it needs to be. So this is the most basic way to do it. We need to copy not just the array, but the whole object, because we need a new object to work with, right? So the way that works pretty much everywhere is we could say return object.assign. And now what object.assign does, it'll copy the values of another object into an object. So what we're doing here is saying, oh, here is a new object with nothing. Then copy our state into that object. So we're creating a copy of it. Oh, I don't want to return this just yet. I'll go ahead and work with an intermediate variable. I don't care. Let new state equal, all right, so I'm mixing so now I've got a copy of that, so I'm not mutating that data. And then the next step, I'm taking a look at what they did, but the next bit here, now we could just do all of this in one line. I'm only breaking it down with a intermediate variable to make it a little easier to see. Now we still, even now, don't want to mutate the array in that, because the interesting part is even though we've created a copy of the object, those things are still pointing to the same actual arrays. So we're going to want to copy our array too. So we'll do new state.notes equals, and this is, we already did this sort of shorthand for copying an array. So we'll spread the, we can do new state.notes, like the existing notes in. Now we want to create a new note, right? And this new note will have an ID of, well, that's it, the tricky part, right? I don't know. I'm gonna do this, which is sort of a hack. I didn't think through how to solve this yet. So the ID is just one higher than whatever our current position is. A little bit of a hack, I know. And then it needs two other pieces of information. It needs some sort of text. Well, we can just say new note, right? That could be something. Is whatever the action.lane ID is, right? So whatever we passed in as our lane ID on this. Yes?
The idea with that hack, would be changing every time I do the email.
Well, we want a new ID every time this gets called. For each new note that gets added to the end of our thing, we want it to have a different ID than the previous notes. Yeah, yeah, it's gonna check it at that point in time. So what'll happen is there's a possibility in other languages that this could be a problem, but in general this isn't in JavaScript, because you could have like a race condition where two things read this at the same time and then have the same value, but JavaScript's single threaded. So what'll happen is, like, if you run this multiple times, the first time it runs, it goes, all right, I'll get my new state.notes. Well, it's only one, right? So my length is 1, so my ID will be 2. And the next time I run it, it'll go, oh, okay, I've added 1 to it. Oh, new state.notes.length, well, that's 2. So now that plus 1 is 3. So the next, I don't have an ID of 3. Yeah, it should increment every time, because your length of your array is getting larger every time.
I think, are you saying that, over time, as you add and delete notes, you will end up in the ID.
When we delete notes, we could have a problem.
Yeah, that's it.
Yes. Yeah. Yeah, that's why this is just a hack. This is just a hack to solve this right now. Like, if I was doing this in reality, I wouldn't do something like this. I would go pull in we talked about a GUID thing, and I would give each one of these a GUID ID or something, so that they would have a unique ID, and then you would never have that problem. So then when I would actually assign an ID here, it would just be like, new GUID. And now, I don't worry about it. Never going to have a collision. They're all unique. It doesn't matter what happens, etc. So yeah, this will have a problem the minute we get to deleting notes, right? Because then I may have multiple notes with the same ID. Because if I've made my array shorter, and now I try to add one, well, the length. So, yeah.
I'm kind of confused with the line 24.
Yeah. So what this does, this is a little bit. You could actually write this out in a syntax very similar to what we did here now. So I'm going to write this out using this other syntax, and maybe because it looks similar, it'll make more sense. So if we say let new state equal this, what we're saying is create a new object, right? An empty object. And you can actually spread like the old state into it, which basically what it says is copy all of the old state, this old object, and put them into this object, but a copy of, but a copy of it, not the same thing. just like we were doing here with this array where it says like copy all the items from our old array and put them at the start of this array. That's all that object.assign was doing. It's just more verbose because object.assign will take any number of arguments, and the first one is the object that you want to change. So in that case, we were giving it a new object, and then everything else is what you want to add into that object. So sort of mixing those objects into it. But they're unique references. All right, so we've got, something here that sort of works. We can always do, if we want this to be much more, much better, even without. Let me see if I can come up with something here that's actually going to work. Uh-oh.
Not a pure function anymore.
I shouldn't really have that. Yep. Because you can't do the same thing. So here's one way to solve this. And this is a little hacky, but it gets to that problem of purity and stuff and being able to reproduce it, is we say, oh, well, if that's what we want to do and we need it to be random, we also shouldn't do new GUID here because that would be random too, right? So instead, what we could do is do it over here. Something in, so it leaves our reducers pure, but we took that impure bit and put it somewhere else, which is just over here. So here we could do like math.random. It should give me a random number between 0 and 1, I believe. Let's see if this will tell me. Yep. So times, I don't know. Times that, and then I'll just math.round, so round down. So this isn't perfect, but it's pretty good chance of getting a random number out of that, right? There's something that won't have a collision. Because all I'm doing is saying, give me a random something, and then round is turning it into an integer, so it's not, doesn't have some extra stuff after it. And then for our ID here, we change this, so it'll be action.id is what we want to assign as our ID, right? So it just modified it a little bit, but it's a little more, less likely to have our problems that we were going to have before. Now we've got one problem, though, we still haven't solved. Okay, so we're dealing with this case. We've created a new state. We've modified it. But we're returning not our new state, right? So we need to return our new state now. Which is great, but this also introduced a problem, which is now we only return something if we actually ran through this bit of code here, because otherwise new state doesn't have a value. So another option here would be to do something like this. Let new state equals state. So we're just initializing it at the beginning to say, and if we don't have anything else, like we're going to start it as state. If we change it somewhere in between, then we're going to return what we changed. Otherwise, we'll end up returning our initial state, right? This makes sense so far? This isn't too complex. We haven't started wiring all the bits up. Always go back to that side. You can see they do it a little different. They just directly return what they're creating in here, which is fine. And then there's a default. And we're going to get to a switch case prob. I don't know if we will, if we'll have something. But usually, most of the time when you're writing reducers like this, you usually do a switch statement instead of an if else. I don't know if we've written switch blocks, but they're just a way to do a much more, if you have a lot of possible conditions, instead of doing like an if, else if, else if, else if, else if, a switch is a simpler way to do it if they're all unique. If you can't have the same, like match multiple, then it's a really easy way to do something like that. All right, so let's see what we've got. We've got, just like them, we didn't mutate our state. We created a copy with, well, not object.assign. but with the same sort of syntax there. Let me get my code running too, because this should be able to be running, although, you know, we're not using it at all in anything, so it probably won't matter right now. So it won't even build that. So I may have some syntax errors that we're gonna have to encounter later. And we're returning the previous state in the case of default, which is important because, and you'll see why that's really important in a little while, because that wasn't just the case where it was important for if it was the initial state or something. It'll make a lot more sense in a minute. So we can add in, now we can get into some of these other conditions as well, right? So we've dealt with just creating a note, but we have at least one other action that we wanted to be able to deal with that we've already created something over here for, and that was creating a lane, right? So we'll keep it pretty minimal and only start with these tonight. But all right, well, we've got another case too. We want to create a lane. So else if action.type equals lane. Similar. We want to change our state, and then we want our new state dot lanes to equal our new state dot lanes. This could also just be state because that's what we passed in, right? Our existing state. We could have done the same thing here, like state dot notes. It doesn't really matter. And another lane that we want to add into it, right? This will probably end up being the same thing because our lanes had, we were giving them an ID of some kind and then a name. Well, that means I'm going to change my create lane over here. I'm going to have it be just like this, where I'm going to add in the ID. That way I'm not mutating something in my function over here. And then my new lane will have an ID of action.id and what was it? Was it name? Again, yeah, a name. And that can just be new lane, right? It doesn't matter. Now we're sort of dealing with both of these, both things that we can do, right? Not that bad at this point, but this is going to get pretty ugly once we start adding in all of the other action types that we can do, right? This becomes a pretty ugly function. Whole bunch of different cases, a little hard to parse, a little hard to understand. We'll start breaking that down in a minute to show how to make that simpler and what we're going to do to help solve that. So that's, hey, look, very next step here. That's the idea of splitting our reducers, right? So if we had a logical split in our data here, the way our data is structured, what might the logical split be about what our pieces are that care about changes? Lane and notes, right? Yeah, makes a lot of sense, right? So here's what I'm going to do. I'm going to go ahead and create some additional functions here. Function lane reducer is what I'm going to call it. And this is actually going to take in state and an action. And just like before, it's going to return some sort of new state of some kind. But what we can do here is we can say, oh, well, this create lane bit here that can move down into our this lane reducer, right? In some way. Except, how are we going to sort of compose this? How is this going to work? Well, let's just move it down here first. We'll make this, simplify some of this, and I'm going to change over, do this new state bit at the top here. So we're saying it equals whatever got passed in, and then return that. And okay, if our action type equals create lane, then we want to modify our stuff in some way and return it. Except does this create lane even really need to know about the rest of the data structure? All it cares, if all it's ever going to do is change lane information, right? So right now, first, before we get there, let's say, how could we use this, right? So if we've got something that can modify, create our new state, well, one thing we could do is we could move it up into here and say, ooh, if create lane, then we'll call the lane reducer, passing in our new state and the action, and assigning that to new state or whatever. That's one option for us here. And then obviously we could do something very similar with create note, right? Where we can make a function which takes in a state and an action. And I'm just going to copy this whole thing this time around because it's mostly the same. Easier to delete the bit that I don't care about. And get rid of that. And all right, now we've got that pulled out, and we could obviously pass this stuff in the same way. We could say new state equals note reducer, new state and action, right? Pretty simple. Now, one problem we have here is what if an action took place that needed to change both pieces of state? So what if one action, like let's go back to the theoretical way we talked about storing our notes before, where we were like, oh, the notes could be an array in the lane, right? If we had it that way, then if you changed a note like order, you may need to change multiple pieces of data, or if you deleted a note, you're going to need to change both the note and the lane information, right? But you really only took one action with that, which was like delete note. So there is a problem with the way this is structured right now, because we don't actually want to do just one or the other. We sort of want to be able to do either one, right? Plus, if we go down into like this note reducer, as I was saying with the lane reducer, it doesn't really need to know about the rest of this state. Why should it know about anything but just the notes? So what we can get to instead is we're going to do something a little different at this top level, where this top level guy here is just going to say, and also I'm duplicating these if checks here, right? So how could I get rid of that duplication? Well, I mean, they really only care about them down in these smaller functions, right? And this thing, let's look at this function now. Is this function directly changing our new state at all? Is it making any mutations to it? It really isn't, right? Because the mutations are happening either in here or in here. All this is doing is getting back whatever was changed. It's not changing it directly. So if it's not changing it, then there's a lot of ways you could, you know, break this stuff down, but one thing that we could do is instead of keeping all this logic here, I'm going to do something where I compose something. I'm going to return a new object. And what are the 2 bits of information that I have at the top level of my state? I have lanes and I have notes, right? And my new lane is an array. So what I can do is I can call the lane reducer. But let's say it doesn't care about, it doesn't need to get passed in my whole state. Yeah, I'll do it right now. I'll pass in my whole state. So I'm even going to get rid of this new state bit here, top level. I'm going to say my lane reducer gets my state and my action, right? And my notes calls the notes or note reducer, which just gets the state and the action. I don't even need any of this anymore. So at this top level, all I did now in my Kanban bit here, the very top level, is it doesn't do anything directly. It just created a new object composed of whatever we get back from these reducers, right? Now that's got a slight problem in terms of this initial state that we set up before. So we could put a condition up here to say like, oh, if you know I don't have any state, then instead of calling down to these, go ahead and return, you know, initial state or something. But another common pattern for it instead is where these bits down here actually get their own bits of initial state. So I'm going to take this initial state and sort of split it out. Initial note state. I'm going to copy it because I'm lazy. Initial lane state. And now I can reduce this stuff even more. And this actually doesn't even need to be an object. It's just an array directly. Because my lanes are just this array of data. Oops. And even our notes is going to be the same way. I don't need any of this other gibberish. I don't need an object. I can bring all this in a layer. And now what I'm going to do is take these 2 things and be what gets returned set as our state here. So my initial note state is just that array. And my initial lane state is the array for lanes. And what you'll see here is the first time this gets called, it's still going to call down to these reducers, which will, in the most basic case, return the initial state for their portion of our data, right? And then it will compose it into this larger object. It'll take those 2 pieces of arrays, assign them to these 2 properties in our object, and return that whole object. Is that making sense? You're beginning to see how it's breaking it down into these smaller pieces, these bits and pieces that we're going to build up, right? So at this top level now, we've got a very, very simple function, and it's just calling down to other reducers to get those different bits and pieces. There's actually even a utility function that exists as part of Redux. Let me see if they use it in their stuff. I don't know if they do. At least in this initial tutorial. They've got one, it looks like they don't either, but they've got one, oh yeah, they do, optionally. There's one called combine reducers, which is a shorthand way of saying like this exact same thing, assuming all of your reducers operate this exact same way. Assuming they follow the same pattern, they take, you know, this bit of state, they take the action. You can use a little utility function to do something like this, but you don't have to. And I think at least at first, it's much more straightforward not to do that. See you later. So we've got a very, very simple bit of reducers, Very simple bit of data. Any big questions on this so far? Should be at least one, like nothing's hooked up. We're not, how do we call this reducer thing? How do we trigger it? How do we connect these bits up, the action creators that we have with our reducers and get everything sort of working, right? So that's the next bit that we're going to go into. But again, pause real fast. Any big questions on this? Following a little bit. There's a lot of code, a lot of concepts. I mean, again, this isn't something at the same level like I expect you to understand as well as React at this point, because I'm sort of glossing over it, but just conceptually at least, hopefully it's making sense. So the store bit, this is where we're going to start hooking all the bits up, right? This is our connections. So we defined our actions, we defined our reducers. The store is, as it says here, it's the object that brings them together. Holds the application state, allows access to state via get state, allows state to be updated by a dispatch action, registers listeners via subscribe listener, handles unregistering of listeners. So the store is very, very simple at the most basic level here. And the way it works, initially at least, like the way you get started with a store of some kind is here. I'm just gonna call it store.js. I'm importing from Redux, importing create store. So the simplest thing to do to create a store here of some kind is to just call this create store method. And what you want to pass it is your reducer, your root reducer, so the top level reducing element, which in our case was called like the Kanban app, or maybe we should rename it and we should call it Kanban reducer. And we're going to want to export that so that it's accessible externally. So now our store needs to import that. And consent. Is this the one that worked well? Nice. Reducers.js, JS on there. And then what I'm importing is the Kanban reducer, right? And that's going to be, so that's what you do to, like, that's creating a store. And all that's doing, like, it does nothing. It just wraps this, this reducer stuff up with all this store logic of some kind. But now we can't do anything with that right now, so we need to assign that somewhere, right? We need a reference to this store. And then I'm going to do this in probably the way that you wouldn't do it originally, at least, but we'll do it in the most basic fashion. I'll just export this store. Oh yes, if I'm exporting and it's not on the same line, I have to use that syntax, unless it's the default. So I'm going to export this store. So what that's basically doing is exporting this object that wraps around our reducers in some way. So now if we have that store and it's been exported, I mean, you don't have to have exported it that way. Usually, in fact, you're going to hook it up a different way. But if we have access to that store somewhere, then what we want to be able to do is now dispatch something against it. See, this is where the store is the thing managing, changing these reducers. We're never going to call stuff directly. All of that's sort of hidden behind the scenes. So let's, where am I going to put this that'll work? This is not the way that you would write something like this, but I'm going to sort of brute force it for the time being, just so that we can see, you know, what we're doing. So I created a, you know, new bare bones React app type thing here. And I'm going to import this store. That's wrong. There we go. Can I call it store? That should work. We'll see. Import my store, right? So I'm doing something very, very simple. And then I'm going to write some functions up here. This is, again, we'll get maybe do something a little nicer, but I'm just going to write some very basic functions so that we can see some stuff going on in our store. So like a function here would be log store, like what they had before. So that might be like console.log store.get. This reference must not be working correctly. Can you do that? All right, that's what I needed to do to get it to work. All right. Store dot, what's one of my methods on here? Get state, I think will work. So let's see if we can make something like this work. Get rid of this. I love this song. Gonna make a button, very simple. And now we're gonna start to see everything that I've got wrong, because I'm sure that something's wrong in all of this code that's been written up till this point. Oh. Module not found. I attempted to import source store store.js, which falls outside of the project's source directory. Did it? What? Shouldn't fall outside of the project. Oh, maybe I needed to do it like this. Let's see if that works. All right, I'm gonna see if this works. There we go. So it worked that way. Now let's see. And this is where you get to see some of the Redux dev tools, which are really, really nice when you're working with something like it. Let's see if it'll find my Redux store. Oh man, no store found. Maybe if I refresh, is it gonna find my store? It might not. So let's see if this worked. Hey, that at least worked, right? We were able to log our store. So we got to see, Redux dev tools probably require me to have it hooked up in some way or pass them into it. So it may not be as easy for me to get these working unless I hook it up to my React stuff correctly. Oh, wait. They've got a sample here that might work. I'm going to try and add this line. Yes, they don't have to. Redux can be used completely independently of React, React independent of Redux. They commonly go together. But Redux is really focused on managing your data layer and not the React, like how it views stuff or anything like that. It's really just focused on how do I change data. So let me see if this will work. To get the dev tools connected. Sweet. All right. Happy. So we can see now is if we went over here and looked in our Redux dev tools, we could look at our state and see whatever our state of our store is. So now we already know we have a way we want to be able to dispatch actions to like create a note, for example, right? So let me minify this. We'll see if I'm going to get all this stuff working. So let's create something else, another function. Create note. And this, I'm not going to call it create note. And this is just for me being lazy. What I want to do here is I don't want this guy to define here the process of how do I create the correct type of action, because that's sort of out of the scope of my React component. So instead, just like before, I'm going to import this. This time, though, I'm not importing my store. I'm importing the action creator. So importing the file that, or the thing that can create stuff. And in there, I have a function called create note, right? So I want to be able to call this. This takes one parameter. Create note, and it takes whatever my lane ID is, right? So we'll just go with one, hard code it right now, which is great, but all I'm getting back is an object out of that. And what I want to do is pass that object into my store so it knows to run that through my reducers. And I'm able, let me double check because I don't usually write stuff this directly against it. Yeah, so since I have a reference to my store here wrapped around my stuff, I can do that by calling store.dispatch. So the store is what's managing this change, right? I'm never directly changing my state. Now I'm going to just copy my little button here, make another one. Add note. Okay, add note button. And this is where it's going to start to be able to do some cool stuff. So if we look here, we've got our initial state, right? Now if I click add note, what should happen is you see we still have our initial state in our history here, but we also have this create note action, because this is the list of actions that we've fired against our store. So every action that's happened will be in this history. And we can see what our new state is. Now we have multiple notes. I've got a structural problem here. I'm putting, my lanes have the lanes and notes. So I'm putting stuff in multiple places, it looks like, or at least initially I did. So there's a problem with my data structure. Let's look at my original here. Lanes, notes. Oh, you know what? You know what I did is when I simplified what I passed in here, I didn't simplify these guys so that they didn't do this. So these guys now should only, yes, I messed up a little bit when I was explaining this. So my lanes needs to get not my whole state, but my state dot lanes. Just a portion of it. And there's some problems with that, right? Because hey, my state didn't have anything. So I'm going to create an empty object so that my initialization of my whole state is an empty object. I want my lanes reducer to only work with lanes, not with everything. And I want my notes reducer to only work with the notes, not with the whole state. That way they don't have to know about the rest of the state. And then the state logic down here can be greatly simplified across these two, because now I don't even have an object that I passed in. I have an array I passed in. So like this here doesn't need to be there. And new state dot notes isn't correct. It's just equals this array, whatever. And it's not state dot notes. It's just spreading my original state, because that's just the portion of the state I'm working with. Just the array of notes went into this guy. And the same thing's going to happen with my lane reducer here. Like this doesn't matter, because actually all it got was the array. And the new state is just the array. And it doesn't need to look at the lanes because its state is just that portion of it. So now those got much simpler, because they can think like, oh, all I got was an array of lanes. All I need to do is know how to reduce that. I don't care about the rest of this complexity. So let me see if that fixed my problem. Let me look at my state here. Yay, now they only have their bit. Lane notes just has a couple notes. And lanes has the one lane that we have right now. And we can add more and see our full history. And what's really cool here is if you look, I can walk back through this and look at every point in time of this history and see what's going on. And you know why it's easy to do that? Is because we never mutated those objects. We never mutated our arrays. We created a new state each time from scratch, right? So we can hold a reference to the old state and keep those pointers around and then have a pointer to the new one for us to do something like this. Like we could say, oh, let me rewind. And now if I click add note, it added something here. Like I could even reset something back. I don't know exactly how to do it right now, but you can reset it all the way back to this and say like, this guy is now my state and I don't want, you know, the other ones again. You can reinitialize back to previous versions of your state. But that's starting to get into the power you get when you're working with Redux and having that consistent history. Yeah?
So just to clarify, with this, having access to every copy of the state as it's changed, that's within the code base in your app, right? It's not, and the Redux tool is just showing us?
No, that's just within the Redux dev tool.
Okay.
Because they wrapped some of, they added some functionality to Redux to give you that history.
Gotcha.
You could do that if you wanted by wrapping something into Redux so that you have access to that full history. But it's really just something for debugging, for your dev history, for whatever, right? Yeah. But you can imagine, I mean, we haven't written very complicated applications here, but imagine you had a user walking through your application. They're doing something. They've been interacting with it, right? Taking different actions, and they got into a weird state, and they've got a bug. I don't know if anybody's ever done this in a game, done this anywhere, right? Oh my gosh, how did this bug happen? I don't know what to do. And as a developer, it's a nightmare when you get this, and you're like, oh man, how did you do this? And they're like, I don't know, I was clicking over here, and then over here a little bit, and then I dragged this down, and then suddenly everything went black. It's really, really nice if instead of that, what you could say, for example, is, oh, why don't you, you know, click the little send log button to me to send me the log of what you were doing, and I'll have a log of the actions that got dispatched against your application to say, oh, these are the exact steps that you took in some way or another. And now I can reproduce it and try and reproduce the bug, hopefully, right? So that, I mean, there's so many different valuable things that you can get out of something like this. That's just a little bit of it. So let me see here. All right, so we've got, there's really only one more piece, and then there's the hooking it up to React, which we're not gonna get to tonight. Hooking it up nicely to React. So we can dispatch events, right? We could add another one here. Because we can already do, we can add a note. We can always do add lane, right? And there we just need to dispatch the event that comes back from our create lane action creator, right? Which doesn't take any arguments. I'll just copy this thing again. Add lane. And now we've got, or should have, an add lane button. And we can intermix our actions and look at our state at any point in time in these dev tools and see, oh, well, we've got 4 different lanes that we've created, and we've got 5 different notes that we've created. They're all by default starting in that one lane, etc. And we can go look at like, oh, here's our initial one. Here's, and if I committed now, I don't know what that just did. Now my state's weird again. Add notes. Oh, it deleted the history so that it didn't keep that stuff around. And there's a lot of different tools you can use here. You can pull this up, and this is a fun one if you're actually doing this in an application, because you can step back step by step through the actions that have happened. You can sort of see it like fading stuff out bit by bit, I guess. So you can be like, walk through the actions and just see your state easily. I mean, different stuff like that. And what would actually happen if we were doing this, rendering of these, then you should see your actual, I believe, values changing over here too, because it'll be changing what is getting sent back. So the last bit, like I was saying, that we haven't done is, okay, we can change the store, but how does anything know that the store changed? How do we like subscribe to something so that we can say like, I want to know when it changed and I want to re-render somehow, right? So the most basic, simple way to do that outside of doing something complex is to do this like store.subscribe. So that's telling you, I want to be subscribed. I want to be notified whenever the state changes. And I want what you pass into store.subscribe is the function that you want to call, right? Whenever the state changes. So it's just a very, very simple, I just pass a function in there. So we can do that bare bones. Again, this isn't the way you would do it in an actual React app because you've got a much nicer way to hook stuff up. But you could easily have like a and let's go ahead and I'm going to add a little bit of stuff in here as well. So we'll actually render these our notes. We'll do something just the most basic way we could do this. Extends a component. All right, I need to write a little bit here. I need a constructor. I'm going to need some state in this guy. He needs to call his super. This state equals store. And I don't want to call anything initially, so I'm just going to even just we'll just say store. I'm even going to initialize it. It's like this. It's not going to have any actual initial values, I don't think. Maybe I don't even need to initialize it here then. We'll see. So then when component did mounts, like the first time it mounts is when the first time I want to do this. And there I'm going to do this .set state. And I want to set that to store.get state. So I'm just getting whatever the current state of the store is, presuming that it's already been initialized by the time this guy gets called. And I want to do one other thing. This dot unsubscribe equals store.subscribe. Store subscriber, that I don't think matches their syntax. Oh, it's because I had that there. No, just store.subscribe. And I want to pass into this whatever the function is I want to call each time I'm subscribed. So I'm actually going to pull this in here. Hold on. This guy is going to become, I'm sort of walking through some stuff pretty rapidly just to hook something up here. But let's do this set state is store.get state. So look, we're just doing the exact same thing. We're just updating it with whatever our new object is each time. We're going to subscribe, and what we want to subscribe with is this dot update store. So that's just what we want to call every time. And the one thing I'm missing is I need to bind this. This is just a little bit of busy stuff to try and get us hooked up so that we will re-render in some way. You know what, before I even do this, let me just try and do the most simple thing I can do. It'll just be like a div, and I will assume that we've got some sort of notes. So this dot state dot notes dot length. I just want to render how many notes we have. Let's see just how bad this is, because I'm guessing something. Maybe nothing blew up. That'd be amazingly lucky if nothing blew up. Cannot read property notes of null. Oh, because I didn't initialize this, right? So this dot state, I'm just going to initialize it to like nothing. We don't have any notes initially in here. All right, let's see. Sweet, we're getting notified each time it changes, right? Look at that. You notice I'm rewinding and it's re-rendering my React app with the state from that point in time now. That's what some of these Redux dev tools let you do, is I can see what happened at those different points in time. So this is a very like bare bones aspect to it, right? What I did was I hooked up directly. Normally you wouldn't be referencing your store directly. Instead, there's a nice little utility bit. They've got a note over here about it, usage with React. So what they have are React Redux bindings. And it's a little weird when you first write them out. So the syntax is a little funky, the way that you hook stuff up. But what you're going to do is basically write some useful little functional utilities and then call this sort of connect, which is this Redux binding, and tell it, oh, this state is mapped to these properties, or the state from Redux is mapped to certain properties in this component. And then when other things happen, I want to be able to dispatch, and here's the component that's connected in some way so that it'll get continually updated. So we may, I might touch on that either at the beginning of the next class, or maybe I'll do a separate short little video talking about that bit. I don't want to hold people any longer. But that's a much cleaner way of hooking stuff up that doesn't end up having your component with these external references to like store littered throughout it. But all it is a nice bit of syntactic sugar for pretty much doing this exact same thing. This is really the hands-on way of doing it. That's just a simpler way of implementing it that doesn't litter this logic throughout a component. And then of course we can change this, right? We can, well, let's not render just a div. Let's render our unordered lists, and let's do this dot state dot notes dot map. And for each one of those, let's get a note. Okay, what do I have here? Yep. Let's get a note and return a list item with note.text. Oops, I need to escape that. Believe. See if that works. And we can now render all of our notes or whatever that we have, right? And we haven't hooked up the lane bits or some of those other bits of functionality, but we've got the construct, the basic idea of it. And the reason, so the last bit I want to say is, you know, this didn't yet solve our problem of all of our data being bound here at the app level. But you notice how this app is hooked up to the store and gets the bit of information out that it cares about and is subscribed for updates and stuff. That's the portion that would allow us to separate this out so that the app doesn't have to know about everything, because we could create a component at our note level, or our notes, we could create like a notes container for all of our notes, and that could be subscribed to the store and pull out just that notes bit knows how to create a new note, for example. So it could update the store. So if we just bind the different components to the store themselves, that's how you could keep it from having to pass all the way through your application, all the way up and down the stack, is having different pieces of your application know how to call this single store and tell it, oh, update the data, create a new note. But the app may not care about that bit of data itself. So that's ultimately how you would get that decoupling that we're going for. Again, like I said, this is a lot of concepts. I've worked with this a lot, and I still struggle with some of these concepts and working with Redux sometimes. There's a lot to it, but it is a very powerful notion in terms of learning how to separate out your data from your UI, having this single source of truth, being able to modify your stuff using this reducer model instead of mutating your data gives you a lot of power, and that can be implemented using different approaches than just Redux. Like, you could do that if you spread your data into different places. You could still say like, oh, never mutate it, only give me something new. And you would get a lot of the capabilities still with a little bit of a different structure. All right. Any questions? Completely lost? Completely? The concept sort of makes sense at least? Because I think that's the best you can hope for the first time you encounter this stuff. If you want a different introduction to it, but in my mind, a really, really, really fast one. And so it's a little hard for, it's amazing, but it's also hard for somebody who's, not an experienced programmer. There's a great introduction here on egghead.io if it still exists. Let me see. Getting started with Redux. This was by the guy who originally created it. And he goes over a lot of these concepts, including like this idea of pure and impure functions again. So up until about here, maybe here, it's not that bad, although he does move pretty fast. Once you get to like this stuff, it starts to feel like it's flying in terms of what he's going through. But it's a really, really good overview of Redux, and it goes into a lot more of how you hook it up to React and the way some of that stuff works than we got into. Yeah. You want me to upload, what's that? Upload this code to GitHub for this? Yeah, I don't have it all hooked up. Let me see. Oh, this is a separate project. Yeah, I'll upload a separate project with sort of what we built today and post a link to that too. Sure. Oh yeah, trust me.